Smart Culture, Mathematics.
In today's lesson, we'll use this shaded region and we rotate it 360 degrees about the x-axis. This solid obtained here is called a solid of revolution. So it's very important that you know what the solid of revolution refers to. Take a look at this diagram. How can we go about determining the volume of this solid? Think about this for a moment. Well, we can calculate the volume of two cones using the specific volume of a cone formula. So because we have a straight line, it will be quite easy to determine the volume in this case. But what happens when this function is not a straight line? If this straight line function is replaced by a curve, the volume calculations will be more complex. And that, of course, is our focus for today. How to go about finding the volumes by integration. Take a look at the following graph. What do you see? Here we have a function, y is equal to f of x. Now this function is not a straight line. So what we'll do now is we'll rotate the shaded region 360 degrees about the x-axis. As you can see, the result will be a solid of revolution, which is often called the volume of revolution. So the solid of revolution and the volume of revolution is the same. Let's imagine that the solid can be sliced into thin disks. If you take a look at this disk, you'll see that it is more or less cylindrical with radius y and thickness delta x. So that means the volume of this thin disk can be calculated by using the following equation. Delta V is equal to pi y squared delta x. Now remember, the volume formula for a cylinder is V is equal to pi r squared times the height. So we just substitute the value for the radius and thickness into this formula, which brings us to this formula right here. The total volume of the solid will be the sum of all the tiny disks as delta x approaches 0. Let's go into more detail now. If we talk about area, when calculating the area of the shaded region, we want to get as close as possible to the actual area. So what we do is we break up the area into little rectangles. We calculate the area of all these rectangles and add them all together. But in order to get as close as possible to the actual area, we let these rectangles become smaller and smaller and smaller, and effectively we do the integration of it. When we calculate the area, we work with rectangles. When we calculate the volume, we work with cylinders. So in order to get as close as possible to the actual volume, we have to apply the same concept as with the area. So we have to make these cylinders smaller and smaller and smaller. So the volume of the solid is the limit of the sum of all these tiny disks as delta x approaches 0. So how can we express this mathematically? Take a look at this. The limiting values of sums like these are also integrals. So it can be expressed as the integral from a to b pi y squared dx. Take another look at this formula. Why do you think are the limits a and b? Think about this for a moment. Why do you think are the limits a and b? This is because x takes values from a to b. Let's take a look at this example question. So first we'll look at the information. The region between the curve y is equal to x squared, the x-axis, and the lines x is equal to 1 and x is equal to 3 is rotated through 360 degrees about the x-axis. Determine the volume of revolution which is formed. So let's visualize this. Let's take a look at the 3D model. So here you can see the volume of revolution. It's always a good idea to start with the formula, so let's write it down. So the volume is equal to the integral from a to b pi y squared dx. Now the value of a is equal to 1 and the value of b is equal to 3. This is given. We also know the function. We know that y is equal to x squared. So let us substitute this into the formula. Now remember, if we go way back to the laws of exponents, this will become x to the power of 4 since 2 times 2 is equal to 4. So now we have the integral from 1 to 3 pi x to the power of 4 dx. So the next step is to integrate. Now remember, if you want to integrate, you have to use this formula. So if we apply this formula, we get pi x to the power of 5 divided by 5 from x is equal to 1 to x is equal to 3. Now let's substitute the value of 3 into this formula. So 3 to the power of 5 is equal to 243. And then we substitute the value of 1 into this formula. 1 to the power of 5 is equal to 1. So we take out pi over 5. And then inside the brackets we have 243 minus 1. That equals 242. So the final answer in this case will be equal to 242 pi over 5 or 152 cubic units. Both of these answers are correct. In the previous example, the solid was formed by rotation about the x-axis. In this next example, we'll work with a solid formed by rotation about the y-axis. For rotation about the x-axis, we used the following formula. Now, for rotation about the y-axis, the formula looks a little different. Take a look at this. So in this case, we substitute for x squared in terms of y. Let's take a look at another example question. So the region between the curve y is equal to x squared, the y-axis and the lines y is equal to 2 and y is equal to 5 is rotated through 360 degrees about the y-axis. So what we have to do is we have to find the volume of revolution which is formed. Again, we'll start with the formula. So you can write down the formula. Remember, we have the values for P and Q. The information is given in the question. So you can replace P and Q. You can write 2 and 5. Here is the function, so let's plug that into the formula as well. So now we have the integral from 2 to 5 pi y dy. Now remember, this y has an exponent of 1. So now we have to integrate. Let's substitute 5 into this formula. 5 times 2 is equal to 25. Let's substitute the value of 2 into this formula. 2 to the power of 2 is equal to 4. So now we take out the pi over 2. And then we subtract 25 minus 4. So in this case, the final answer is equal to 21 pi over 2 cubic units.
For online tutoring or additional resources, visit our website, www.smartculture-education.com.
Subscribe down below. It's easy.